Welcome to this course by RouteFabric. In today's session, we are going to cover the data science process and various tools that we use when we go about doing data science work. Now, I've summarized the data science process in this high-level diagram, and we're going to keep our discussion today very high level. Data science starts with capturing and collecting information and then storing it in a place that is accessible and usable by a data scientist. After you've collected enough data from usually a variety of different data sources, next step is to prepare and clean the data. That process usually takes maybe 70 to 80% of the effort in the entire data science process. Data is almost always very messy and typically requires a lot of cleaning and preparation before it can really be used by various tools that we use to analyze and to build models. So we capture and collect, and then we store. We prepare and clean that data to get it ready for analysis. And then there's really two steps of the analysis that we typically do in data science before we can go and build predictive models and really do traditional data science model building. We first need to just explore and typically visualize while we're exploring the data to really kind of get to know the data and understand how it behaves and what it looks like, what the distributions are, how many observations, how much missingness there is in the data. Once we're familiar with the data and we can consider the data our friend, then we can proceed to the last step in the data science process, which is using data to build predictive models in order to solve some problem. When we build those models, we ultimately, hopefully, put them into use, and we will talk about that in a later session. So this is an overview of the data science process. You can check out our other course on the using a case study of this data science process to really get an in-depth look within each of these 5 stages of the data science process. But this is the high-level overview that we'll reference quite a few times. By the way, there's a thermometer over there on capture and collect, because that's just a representation of measurement. The data that we collect is, of course, different than just temperature data. Now, there's a few different categories of what we call algorithms. And I want to give you just a high-level summary of what those different kinds of algorithms are and what they're used for. So first of all, an algorithm is really just it's a process of finding patterns in data. And over decades, very smart mathematicians and statisticians have discovered various ways to find structure and patterns in data. And different algorithms can be used to solve different types of problems. Now, there's many algorithms out there, regardless of what programming language you decide to use and what problem you're trying to solve. There are going to be many different algorithms for you to choose from. But it's helpful to understand the themes in the different kinds of algorithms. And really, I'm going to go as high level in this discussion as just separating them into 2 groups. The first group that we'll talk about is what we call supervised learning algorithms. Now, these algorithms require what we call ground truth, meaning we need to know when we go and we're trying to find patterns in data, we need to have that data be describing something that we, the humans, we already know kind of what happened or what the outcome was. And then we are going to be using machine learning algorithms to try to teach a machine to understand those patterns and to try to help us make prediction for the future. So supervised learning algorithms use ground truth. And some of that ground truth data might be people who we knew were fraudulent. Out of a batch of maybe credit card transactions, there's going to be a handful that we have identified over maybe the past year of a fraudulent transaction. And because we know that ground truth, we can then use that information to try to teach a machine what it looks like when someone is trying to commit fraud. And in so doing, we train a model. So we use some of that ground truth data to train a model, or in other words, to allow the algorithm to learn how to distinguish between people who are trying to commit fraud and people who are just normally transacting with their credit cards. So a supervised learning method is where we as humans are overseeing, or we're kind of guiding the algorithm to learn what we have already observed. And in that way, we kind of call this learning to be supervised learning, because we're the ones guiding the machine and telling it which ones were, in this case, good and bad, fraudulent and not fraudulent. These supervised methods are probably the ones that you might be the most familiar with from a distant math class in the past. So things like linear regression or classification, or some more advanced methods like random forests or neural networks. These are all cases where we are trying to train or supervise a machine's learning so that that machine can become very good at predicting people who we haven't seen yet, or observations that we haven't seen yet. Of algorithms. In contrast to those supervised methods, we call these unsupervised learning or unsupervised algorithms. And these algorithms are used when we don't know a ground truth. And the objective is instead, rather than having the machine predict something as good or better than we as humans could predict, or trying to help us understand something that's going to happen in the future, the objective here instead is to allow the data to describe itself. And we use algorithms to find patterns in data that tell us about its inherent structure. Because there is no real ground truth, these algorithms are really designed to kind of be blind to what outcomes may exist or not in the data, and really they just go and they look at the data and they try to find structure in that data. The classic example of an unsupervised method is a clustering algorithm. So one popular method for clustering is called k-means clustering, where the algorithm looks in the data along a variety of dimensions or variables and attempts to group or cluster the data into like groups or into similar groups. So on the left there, before k-means has been applied to the data, we just see a bunch of black dots. And those black dots, we may or may not be able to categorize them very effectively as humans, but we can use algorithms like the k-means clustering algorithm to understand and learn that there is an orange group and a red group and a blue group. This is conceptual, so I don't know what those colors mean, but that's an example of how clustering works. So between supervised and unsupervised learning, that really encompasses most of the algorithms and types of data science and machine learning that you're going to come across. You'll probably more often, in terms of predictive analytics, supervised methods are very popular in the things that are most heavily used probably by organizations and in attempting to make predictions. But we'll also do an example of a clustering algorithm that is also very useful and that can be used by organizations. So that's a high-level overview of the data science process and of the things and concepts that we use when we go to build or find structure or find patterns in data as we go about data science. I also want to talk, just in case you're new to this data science world, I want to give you a really quick crash course in the tools that are out there and available for you. Now, in today's data science world, there are other programming languages out there, and many data scientists choose to use those as well, but by far the most popular two languages are Python and the language R. These two languages have a incredibly active and robust community, open source community, where data professionals and data hobbyists from around the world contribute code and packages and libraries and improve algorithms and just make our lives as data scientists collectively easier. And so if you're new to data science and you're going to go pick up one of these languages, then you certainly would want to start with one of these two, either R or Python. And really both have their pros and cons. I happen to be very active in the R tools, and I'm very familiar with R and RStudio. Python is a little bit more programmer friendly, and it's much more of a sort of a programming language as opposed to R, which is quite procedural and maybe a little bit more readable. But those are your two languages. And then IDEs available. There are others, of course, but if you're looking to just get started with data science, IDE stands for Integrated Development Environment. And hopefully you've heard of the IDE for R, which is called RStudio. RStudio is probably, it's typically considered the flagship sort of data science IDE environment, and it's quite incredible, and it's very well suited to data science work, and it's something that I work in every day, all day. Now there's not quite as much consolidation on the Python front when it comes to IDEs. The one that is probably most like RStudio would be Rodeo, I think is how it's called. I don't know if Y is part of the title that you call it, but anyway, Rodeo is a Python development environment that is sort of modeled after the RStudio model, and it's very user friendly and quite similar to RStudio. There are for sure other IDEs out there, but Rodeo, if you're looking for something that's fairly accessible and will get you up and running fairly quickly, then Rodeo is a great one to check out. And then I just have two other columns here to point you to the areas of code, or sort of the core libraries that are going to get you started and very quickly familiar with what is just being used in modern data science. In the R community, there is a suite of packages that has been labeled as the tidyverse, and you can look up and Google why it's called the tidyverse, but it is a suite of packages that have been brought together in a single master package, so to speak. And the tidyverse is it's one method of interacting with code and with data, a method that I find very user-friendly and very powerful. And there's a lot of people who really enjoy coding and doing data science within the tidyverse paradigm. So that'd be a great place to get started if you want to get started with R. One of the visualization packages, one of the packages within the tidyverse that is dedicated to visualization is called ggplot2. And technically it's part of the tidyverse, but it's a wonderful and very flexible visualization framework, and any data scientist should be able to interact with and build visualizations inside of R, or inside of your language of choice. And ggplot is definitely the place to start if you're going to be doing so in the R environment. Now on the Python side, it's a little less consolidated again, but there is a core package or library called the Pandas library that has, in many ways, become the standard for data science work. And that library and the community built around the Pandas data frame paradigm is very robust, and it's very active, and there's rich contribution history there. And that's the thing that you should learn first if you're going to be doing data science inside of Python. There are other related packages like NumPy, and for actual data science and predictive analytics, there's probably scikit-learn is the package that you should be exploring, but the Pandas is the place to start in terms of libraries that you should know and understand. On the visualization front, it's even less consolidated on the Python front. Seaborn is just one of quite a few very powerful visualization frameworks. So that would be one place to start. You can also look at matplotlib is the name of that library. There's also actually a version of ggplot2 that has been ported to the Python language, and that would be another place to take advantage of the very layered approach available within the ggplot2 paradigm. So these tools, if you choose one of these rows in this table and learn everything that you can about everything on that row, then you will be well on your way to learning how to be a data scientist. Now, there's lots of courses. There's actually quite a few free courses out there. There are other courses on RouteFabric that'll take you through and explain how to do different things in R and in Python. So there's lots of resources out there available to you. But this is the core place that I would suggest that you start if you're looking into starting and being familiar with data science. I'm going to add on to this list, but claim also that this edition is out of scope for this particular course. Much of data science today happens within cloud-based processing environments. And so another suite of tools that you should become familiar with if you're serious about data science is using tools that are available in cloud environments to help you to write and process things in a scalable manner. Now, that's a very broad topic and not within the scope of this session and this discussion, but that would be another thing that you should probably learn. The AWS environment has a very large suite of tools. Similarly, Microsoft's environment has a set of competing tools in the Azure setup, and becoming familiar with one or maybe both of those suites of cloud-based tools would be maybe an advanced topic for a data scientist as you grow on your data science journey. I would start, of course, with these introductory tools that you can just run locally on your own computer, and you can grow and expand into the cloud infrastructure space. Okay, that's it for data science processes and tools. I hope you enjoyed this and that it was informative. If you'd like to know more about data science and about the overview and just understanding and getting started with data science, you can check out our other courses at routefabric.com. Thanks.